Hello student, good morning. Welcome to online class. Today we are going to study about SCR, DIAC and TRIAC. Aim of this experiment is to study SCR, DIAC and TRIAC. List of electronic component with specification. SCR silicon control rectifier. The number of SCR is BT151. Specification sensitive gate thyristor. Quantity required 1. DIAC. The number is of DIAC is DB3. Specification two-way trigger diode. Quantity required 1. The another component is TRIAC. The value of TRIAC is BT136. Specification of this component is two-way AC switch. Quantity required 1. Theory regarding SCR, silicon control rectifier. SCR is a 4-layer PNPN device. An ordinary rectifier diode and a junction transistor are combined to form PNPN device. It has 3 terminals, namely anode, gate and cathode. Symbol of SCR and construction detail are shown in figure. SCR has 3 pin. SCR has 3 PN junction J1, J2, J3. Working of SCR. When gate is open, the SCR circuit with gate open is shown in the diagram. That is no voltage applied to the gate. Under this condition, junction J2 is reverse bias while junction J1 and J3 are forward bias. Hence, no current flow through the load RL and the SCR is in cutoff state. If the applied voltage is gradually increased, a stage is reached when reverse bias junction J2 break down and the SCR conduct heavily. This stage of SCR is called on stage. The applied voltage at which SCR conduct heavily without gate voltage is called breakover voltage. Second condition, when gate is positive with respect to cathode. The SCR can be made to conduct heavily at smaller applied voltage by applying a small positive potential to the gate as shown in the figure below. Now junction J3 become forward bias and junction J2 is reverse bias. The electron from N-type semiconductor start moving across the junction J3 toward left, whereas hole from P-type toward the right. Consequently, the electrons from junction J3 are attracted across junction J2 and the gate current start flowing. And anode current also increases, so more electrons are available at that junction J2. This process takes place continuously in small time. Junction J2 break down and SCR start conduct heavily. Once SCR start conducting, the gate loses all the control. Anode current cannot be controlled by reducing gate voltage. The way to stop conduction is to reduce applied voltage at 0. Application of SCR. Application of silicon control rectifier. SCR is used as a high power electronic switch. SCR is used in rectifier circuit. SCR is used as a solid state static contractor. SCR is used for speed control of DC shunt motor. SCR is used as high power controller. SCR is used as an overlight detector. DIAC. The DIAC stand for the diode AC switch. It is a two-terminal bidirectional switching devices. That is, it can be used in either direction. The symbol of for DIAC is shown in the given below figure, which has two arrow in both direction, which means that it conduct for either polarity of the supply voltage. A diode do not have a controlling terminal as a gate in case of thyristor devices. Construction. The construction of diode is look like a transistor. The doping concentration in all the layer in DIAC are identical. The three regions in DIAC are equal in size. The DIAC can be fabricated into 3, 4 or 5 layer structure. A 3-layer structure is more commonly used than other structure. The 3-layer DIAC can be constructed in either PNP or NPN structure. In PNP form, two terminals are connected to the outer silicon P region separated by N region. The structure is same as PNP transistor with no base connection. The 3-layer structure of diode diagram is shown below. Consider the PNP crystal structure in which terminal 1 and 2 are connected to the P1 and P2 outer layer respectively, which are separated by N layer. When the terminal T1 is positive with respect to terminal T2, junction P1N is forward bias and P2N is reverse bias. When the breakdown voltage of P2N is reached, the entire structure come into the conduction mode and hence diode conduct from terminal T1 to terminal T2. The reverse will happen if thermal T2 is positive with respect to terminal T1. Working. As soon as the supply voltage, whether positive or negative, is applied across the terminal of a diode, only a small leakage current flow through the device, so the device operate in either forward or reverse blocking mode. When the applied voltage is increased to a value such that it is equal to the breakover voltage, an avalanche breakdown occurs at the reverse bias junction. Then the diodes start conducting and exhibit negative resistance characteristic. That is, the current increases with decreasing value of applied voltage. The voltage drop during the conduction is very less and is equal to the on state drop of the diode. The current flow increases quickly when the diode comes into the conduction mode. Therefore, for a safe operating level of this condition, current in either direction, a resistance is connected in series with the diode. VI characteristic of diode. Figure shows the VI characteristic of diode which indicate the current flow through the diode with respect to the voltage across it. as long as the voltage across the diode is within its breakover limit, that is from minus B0 to plus B0 BO, the resistance offered by the diode is very high. So a small leakage current flow through the device for applying positive voltage which is less than plus VBO and negative voltage less than minus BO as shown in figure. The region OA in the portion of the characteristic is the blocking region. Under this condition, DIAC operates as an open switch with the voltage plus VO and minus VBO are the breakdown voltage which are generally in the range of 30 to 50 voltage. Once the positive or negative applied voltage is more than the respective breakdown voltages, that means at point A in the above figure the diode begin to conduct and the voltage drop across the device becomes few volt. The portion AB represents the conduction of the diode. This conduction continues until the device current falls below its holding current level. From the figure, it is noted that the holding current and breakover voltages values are identical for reverse and forward region of the operation. The first and third quadrant characteristic represent the forward and reverse bias condition of the diode. Applications of DIAC. DIAC is used as light dimmer. DIAC is used as a heat controller. It is used to control speed of universal motor. It is used mostly in power electronics where bidirectional switching characteristic is required. It can be used as triggering device in TRIAC power control system. TRIAC. The major drawback of an SCR is that it can conduct current in one direction only. Therefore, an SCR can only control DC power or forward bias half cycle of AC in a load. However, in an AC system, it is often desirable and necessary to exercise control over both positive and negative half cycle. For this purpose, a semiconductor device called TRIAC is used. A TRIAC is a three-terminal semiconductor switching device which can control alternating current in a load. TRIAC is an abbreviation for triode AC switch. Tri indicated that the device has three terminals and AC means that the device control alternating current or can conduct current in either direction. Construction. A TRIAC is a three-terminal, five-layer semiconductor device whose forward and reverse characteristics are identical to the forward characteristic of the SCR. The three terminals are designated as main terminal MT1 and main terminal MT2 and gate G figure shows the basic structure of TRIAC. As a TRIAC is equivalent to two separate SCR connected in inverse parallel, that is, anode of each connected to the cathode of the other with gate common as shown in figure. Therefore, a triac acts like a bidirectional switch, that is, it can conduct current in either direction. The figure shows the systematic symbol of a triac. The symbol consists of two parallel diodes connected in opposite direction with a single gate lead. The gate provides control over conduction in either direction. The following points may be noted about the triac. The triac can conduct current with proper gate current regardless of the polarities of the main terminal MT1 and MT2. Since there is no longer a specific anode or cathode, the main lead are referred to as MT1 and MT2. A triac can be turned on either with a positive or negative voltage at the gate of the device. Like the SCR, once the triac is fired into conduction, the gate loses all control. The triac can be turned off by reducing the circuit current to the value of holding current. The main disadvantage of a triac over SCR is that triac have considerably lower current handling capabilities. Most triac are available in rating of less than 40 ampere at voltage up to 600 volt. Working figure shows simple triac circuit given below. The AC supply to be controlled is connected across the main terminal of the triac through a load resistance RL. The gate circuit consists of a battery, a current limiting resistor R, and a switch S. The circuit action is as follows. With switch S open, there will be no gate current and the triac is cut off. Even with no gate current, the triac can be turned on provided the supply voltage becomes equal to the breakover voltage of the triac. However, the normal way to turn on a triac is to introduce a proper gate current. When switch S is closed, the gate current starts flowing in the gate circuit. In a similar manner to SCR, the breakover voltage of the triac can be varied by making proper gate current to flow. With a few milliamperes introduced at the gate, the triac will start conducting, whether terminal MT2 is positive or negative with respect to MT1. If terminal MT2 is positive with respect to MT1, the triac turns on and the conventional current will flow from MT2 to MT1. If the terminal MT2 is negative with respect to MT1, the triac is again turned on, but this time the conventional current flow from MT1 to MT2. The above action of triac reveals that it can act as an AC contactor to switch on or off alternating current to a load. The additional advantage of triac is that by adjusting the gate current to a proper value, any portion of both positive and negative half cycle of AC supply can be made to flow through the load. This permits to adjust and transfer of AC power from the source to the load. Characteristic of triac. VI characteristic of triac is shown below diagram. The application of triac. Triac is used as a high power lamp switch. Triac is used in fan regulator or any speed control circuit. It can be used as a AC contactor. It can be used in electronic changeover of transformer taps. Conclusion of this experiment: SCR, TRIAC and DIAC has been studied. There is some oral questions for you. Please note it down in your copy and show me later on. The first question is, what do you mean by SCR? Draw symbol of SCR, DIAC and TRIAC. Explain working of DIAC. List the application of TRIAC. List the application of DIAC. Explain construction of SCR. List the application of SCR. Okay, thank you student. Meet you in next period. Thanks.